Hello guys, in this video we are going to find the derivatives of the trigonometric functions. So derivative of sin x would be equal to cos x, derivative of cos x would be equal to negative sin x, derivative of tangent x would be equal to secant square x, and the derivative of cot x would be equal to negative cosecant square x. Derivative of cosecant x would be equal to negative cosecant x multiplied by cot x, and the derivative of sec x or the secant x would be equal to secant x multiplied by tangent x. Now don't worry, you do not have to memorize all of these formulas. We are going to solve multiple questions in this playlist. So I have never recommended anyone to memorize the formulas or learn the formulas or cram the formulas, because maths is all about playing. So the better you are the player, the better you are at math. We will solve a couple of different practice questions related to the trigonometric functions so that you won't even have to memorize these things. They would be at your fingertips. And secondly, don't worry about the proofs. I will upload the proofs of all of these results. These are actually the results. These are actually the theorems. Okay, so I will upload all of the theorems separately in other videos, but for now we have to differentiate using the first principle method. Now what is the first principle method? You can check out this video if you do not know what is the first principle method. This is the very first video of this playlist, the differentiation playlist. We have to differentiate cos2x with respect to x using the first principle method. Y is equal to cos2x. Now let's just begin with the first method. We will, first of all, if you're using the first principle method, we have to apply the increment on both sides of the equation. First the increment in the independent variable x, and then the increment in the dependent variable y. Then we will move this y towards the opposite side of the equation. We will have cos 2x plus delta x minus y. Now what was the value of y? It was this cos 2x. So cos 2x plus delta x minus cos 2x. If there is a cos over here and there's a cos over here, and you can see that this is 2x plus delta x and this is 2x. So I can actually label this as alpha and this one would be my beta, and this actually leads me to another identity of cos. What is that? Cos alpha minus cos beta would actually be equal to negative 2 sine alpha plus beta divided by 2. This is a half angle identity multiplied by the sine alpha minus beta divided by 2. This is the identity which we will prove in some other videos, in future upcoming videos. So don't worry about it. But for now, cos alpha minus cos beta is actually equal to negative 2 sine alpha plus beta divided by 2 multiplied by sine alpha minus beta divided by 2. So this would be my alpha, this would be my beta. I can actually write negative 2 sine, what is my alpha? It is 2x plus 2 delta x. I've just multiplied this 2 inside these terms, so that's not the big of a deal. Plus beta, what is beta? 2x plus 2x divided by 2 multiplied by sine, what is alpha? 2x plus 2 delta x minus beta. What is beta? Negative 2x divided by 2. So this is the final thing, and let's begin. This would be 4x and this would be cancelled. So I will have, this would be 4x plus 2 delta x divided by 2. This would be sine 2 delta x divided by 2. Negative 2 sine. Okay, now we will take out this 2 common, and this 2 is already common. I can take out this 2 common. It would be 2x plus delta x divided by 2 multiplied by sine. This 2 will be at the beginning. 2 delta x divided by 2. This 2 is cancelled and this 2 is cancelled. So what is remaining? Negative 2. Now this was the first step. Now what was the second step of first principle method? We have to divide these terms by delta x. So this is delta x. Delta y divided by delta x. Now what was the third step? We have to apply the limit. Okay, so let's apply the limit. Wherever we will be having delta x, it would actually be equal to 0. Now before applying the limit, I can actually write this thing as negative 2 sine delta x divided by delta x. I can just put delta x beneath this term, because you know what, these terms are actually being multiplied. Okay, so I can put delta x beneath any of these terms. Okay, so I'm putting it under sine delta x divided by delta x. But why specifically sine delta x? Because there's an identity. If sine delta x is over there and there's a delta x in the denominator, it would actually be equal to 1. That's an identity. So this would actually be 1. I will actually write this 1. That's not the big of a deal. After that, yeah, there's one thing. I cannot actually write sine delta x. For this thing to actually be equal to 1, you need to have a limit of delta x approaches to 0. Okay, this is a very important thing. If you are having sine delta x divided by delta x with the limit, you can actually write it 1. Okay, so I cannot write 1 over here directly. First of all, I have to give this sine delta x divided by delta x a limit of delta x. then I can put a 1 over there. Okay, so now I have just put the 0 over here because the delta x was actually existing over here, and when we apply the limit of delta x approaches to 0, we will have to put delta x equal to 0 anywhere in the equation we are having delta x. So now negative 2 sine 2x. Now I told you that if you are having limit of delta x approaches to 0 and sine delta x divided by delta x, this term would actually be equal to 1. So I will write 1 over here. Negative 2 sine 2x. This is the final derivative of cos 2x according to the first principle method.